Welcome to the deep dive. Today, we're cutting straight to the chase on the state of large AI models.
Yeah, and our focus is really the strategic thinking happening inside Google and DeepMind, especially right after the launch of Gemini 3.
Exactly. We've pulled together the latest insights, directly from the people building these things, their strategy, their focus, and where they really think the frontier is moving.
That's right. And what the sources show is this incredibly high-stakes mission, figuring out how they actually plan to build artificial general intelligence.
But the context they give really reframes the whole thing, doesn't it?
It does. They're very clear. This isn't some, theoretical research project locked away in a lab. They explicitly call the AGI. They're building a joint effort with us in the world.
And that phrase just changes the stakes completely. It means AGI's success is tied to how we all use it every single day.
Hmm.
And if you've been watching the space, you might be wondering if this frantic pace can even last. But according to them, progress has not slowed down.
No, and they seem to think the next 6 months are going to be probably just as exciting as the last 6 months.
It was just a wild thought.
It's a massive acceleration. And that pace, it forces us to, rethink what progress even means here. Which brings us to our first big theme.
Okay, yes, let's start there. The real measure of progress. So when Gemini 3 came out, the initial reaction was super positive.
Right, and on the leaderboards, the standard tests, it looked awesome.
But the sources are quick to caution that, a good score is just the beginning.
Precisely. Benchmarking gives you that initial crucial validation, but the developers stress that the ultimate test, the real test,
Right.
is putting the model in the hands of users.
That feedback loop.
It's everything.
Yeah.
It's seen as way more important than any single score. Because benchmarks, well, they're a fleeting measure in machine learning. They define a challenge for right now.
And then the tech progresses,
Yeah.
and the benchmark is suddenly irrelevant.
Obsolete. You have to define a new one. It makes total sense.
It's like you spend months climbing this really hard mountain, you get to the top, and then you see the actual goal is the whole mountain range behind it.
That's a great way to put it.
So can you give us an idea of just how fast these goalposts are moving?
Yeah, okay, so take two specific benchmarks, HLE and RKGI2. A little while ago, models were terrible at these. We're talking like 1 or 2% success.
So basically random guessing.
Exactly. But with new advancements, especially something they call deepthink, those same models are now getting over 40%.
Wow. From 1% to 40.
It's a massive, massive leap in a really short time. The problem that HLE and RKGI2 represented is, for the most part, solved. Now they have to find harder problems.
But I know some benchmarks are sticking around. If the models are getting this good, this fast, what's holding steady?
That would be something like GPQA Diamond. It's still around because it has really hard questions that the models are still struggling with.
And for you listening, GPQA Diamond isn't just trivia.
No, not at all. It requires expert-level scientific reasoning, deep, multi-step thinking, often with really obscure concepts. So while they're getting closer, it's a good reminder that some really hard problems in reasoning are still unsolved.
So if the tests keep changing and the focus is moving from the lab to the user, what's the ultimate measure of success for this whole AGI thing?
It's all about utility. The sources are crystal clear on this. The most important measure is the model's application in the real world.
How people are actually using it.
Yes. Are scientists using it? Students, lawyers, engineers? Is it for easy tasks like summarizing an email, or is it for really hard domain-specific problems? If it's delivering real value across the different fields, that's progress.
Okay, but I wonder, is framing it as utility just a smart market strategy? How do we know that optimizing for a product like search is really pushing AGI forward and not just, pushing Google's bottom line?
That's a fair point. The argument from the sources is that integrating into products forces robustness. A model that only works in a sterile lab environment is, well, useless.
Well.
But a model that can handle the sheer chaos of billions of real-world queries, different languages, different intents, that's how you expose its weaknesses and actually push the architecture forward. They're using the world as the ultimate stress test.
That really clarifies that co-building with the world idea.
Yeah.
Okay, so if that's the outside-in view, let's look inside the labs. Where are they focusing their efforts? What's their hill climbing strategy?
So they've identified three really critical areas. First, and maybe the most important, is instruction following.
Reliability.
Total reliability. The model has to understand the precise, nuanced request. It can't just answer what it thinks you want. It has to follow the instructions to the letter. That's what moves it from a clever chatbot to a reliable tool.
And given Google's reach, the second one, internationalization, must be a huge focus.
Oh, absolutely. Gemini 3 Pro showed huge improvements in languages that historically weren't great. And strategically, it's about getting that user signal from everywhere. If it only works perfectly in English, your feedback is so limited.
You're only stress testing one part of its brain, essentially.
You got it. To scale AGI, it needs to be useful in Hindi, in Portuguese, in Swahili, everywhere.
Which brings us to the third focus, and this is where it gets really exciting, I think. Agentic actions and code.
This is what they see as a whole different multiplier of intelligence. We're talking about function calls and tool calls.
So the model isn't just answering, it's doing things.
Exactly. It's reasoning about when to use an existing tool, like pulling data from a spreadsheet. But the next level is the model writing its own tools on the fly.
And code seems so central to this whole vision. Why?
Because code is how you bring anything to life in the digital world. If an AI can reliably write and execute code from a high-level idea, it just unlocks so much creation.
And they use this anecdote, this idea of vibe coding.
Yeah, vibe coding, it sounds less technical, more cultural.
What does it mean?
It's the idea that the AI can make creative people who aren't hardcore programmers, productive. You don't need to write out every function. You just give it a concept, a vibe.
And it generates a working app.
A working app, a piece of software. It basically democratizes building. It turns more people from consumers into creators.
That shift from research to global utility must require a massive operational change, which takes us to building AGI with an engineering mindset.
Right. This moves beyond the whiteboard. This is systems thinking.
So tell us about the chief AI architect role. How does that fit in?
That role is all about making sure every single Google product has access to the best AI tech available immediately. The goal is still technology development, not product development, but the two are now completely intertwined.
And that's essential for that feedback loop we keep talking about.
Exactly. They say AGI is being co-built with our customers through this integration. Think about the user signals they get from the Gemini app or the AI overviews in search
or this new platform, Anti-Gravity. We should pause there. What is that?
It's their new agent coding platform. It's designed to make it easier to build and deploy AI agents. By putting it in the hands of developers, Google gets real-time data on how the model performs on complex, real-world tasks.
And that data shows them what's broken.
What breaks, what's confusing, where the model hallucinates, all the stuff you need to know to make real architectural improvements.
So it's not enough for the model to be smart, in theory. It has to be safe and robust when millions of people are hammering on it.
That is the core of the engineering mindset. Safety and security are a first principle. They're not bolted on at the end. They're built in from pre-training through post-training, all of it.
That sounds like a logistical nightmare. The scale must be immense.
It's ease. It's logistical warfare. They describe Gemini 3 as a true Team Google global effort, thousands of people across continents. The model design has to be coordinated with the hardware it will run on.
They're co-designing the software and the hardware.
At the same time, the chips, the data centers, the networking, it's all one system now. That's how you get to global scale robustness.
Wow. An industrialized approach to intelligence.
That's a really good way to put it. It's systems engineering for cognition.
So let's connect this back to its origins. Let's talk about the DeepMind legacy and future innovation. How does this systems approach connect to their history, especially with multimodality?
Well, multimodality, understanding text, images, audio, it's not new for them. If you go back 10, 15 years, the focus was heavily on images. I remember early work on models like Pixel CNNs, for example.
And then text just exploded.
Right. Text became the domain for that exponential progress. But now the sources say the architectures for text, image, audio, they're all naturally merging.
Oh, it's not a forced thing.
No, the underlying math is just converging. The idea is that world knowledge you gain in one area should immediately help in another.
And they gave that example, the image generation model. Nano Banana Pro.
Exactly. It's an image model, but it's built on top of the Gemini 3 Pro text model. It relies on the text model's deep world understanding to handle complex
Like
tasks,
what?
like generating a detailed infographic from a dense, complicated document. It needs to understand the meaning, semantics to lay it out logically. It's not just painting by numbers.
That cultural foundation must be so important. I was amazed to learn that the current CTO, Kavukcuoglu, was the very first deep learning researcher at DeepMind back in, what, 2012? 2013.
That history is everything. The way they learned to organize these huge teams came from projects like DQN, which played Atari games.
And of course, AlphaGo and AlphaFold.
Right. Those projects were about getting large, specialized teams, sometimes 25 authors on one paper, all focused on one mission. That's the cultural backbone for Gemini today.
They mastered the science of coordinated discovery.
I think so. They learned how to turn research into a mission. But even with all that success, they still see a huge risk.
What could possibly be the biggest risk?
This was the most humbling insight for me. The developer admits they do not believe they have the AGI recipe figured out. They feel the core breakthroughs still haven't happened. So the single biggest risk is running out of innovation. Not money, not compute, running out of new ideas.
That admission is just incredible. And it explains their journey. They talked about feeling like they were playing catch-up just a few years ago.
It's a key part of their drive. 2.5 years ago, when this LLM push really started, they felt they were nowhere near what is state-of-the-art.
They felt like the underdog.
Completely. And that feeling forced them to innovate for ourselves in a really aggressive way, to catch up and join what they call the leadership group. It's a story of internal desperation driving innovation.
What a journey. From the first researcher to leading this massive global effort.
And the synthesis for you, the listener, is pretty clear. AGI development has fundamentally changed. It's inseparable now from the user experience. It's driven by utility and scaled by this high-level engineering mindset.
And the pace. It's not slowing down. The next 6 months are going to be probably just as exciting as the last 6 months.
It is an absolutely extraordinary time to be watching all this unfold.
So we heard that the biggest risk to the Gemini program is running out of innovation. If user feedback and solving real-world problems are what's driving new ideas now, what current unsolved real-world problems, something outside of traditional benchmarks like GPQA Diamond, do you think will force the next major architectural breakthrough in AI? Something to think about as you reflect on how these models are really being built.